So to start, though, I was asked to cover briefly the new R pipe. And so there's a sort of a rule for anybody who teaches programming that you never update anything while you're teaching because it could break everything. And so I have not updated to the newest R 4.1.0. Okay, so I don't actually have this capability yet. If you have updated, great. If not, then you will not. All right, this has been in the works for quite a while now, but it officially went live with R 4.1. Okay, and what it is a base version of the pipe. So now, theoretically, you won't have to load Magrittr to have the pipe or dplyr or any of the tidyverse because they export all of the tidyverse packages that export it. Okay, so this is like the standard code, right? And this same code can be written like this with the base pipe. And you might be thinking, well, like, what in the world is that symbol? Because it looks kind of neat, but I don't know how to type that. Well, this is just actually using what are called ligatures to make it look a little more fancy. But all you do is it's a bar like that, and then a greater than symbol. That's the base pipe. Okay. So, but then if you're using ligatures, it'll end up looking like this, which is kind of nice looking, I think. And so you can see for simple things like this, it works exactly the same. So that's really nice. You can set key bindings up too so that you have the same shortcuts as you had before. And the main benefit is now you don't have that dependency. But there's some downsides to it also. So this is going to work the same. But when we get to something like this, the Magrittr pipe is really nice because the first, by default, right, always the whatever's passed into it goes into the first argument of that function. But if you want to put that argument somewhere else, like in this case, we have empty cars, we're piping it to LM, then we can just put a dot where we want the data to go. With the base pipe, it's a little more complicated. You have to do something like this. So you have this, and then you have to wrap this whole thing in function X, and then you put X there, and then you have this like little, they call it an I, right? So it's like just empty parentheses pair. And that'll do the same thing. It's a little more ugly. The other thing you can do are these, they're called Lambda functions. Okay, so this works like this. So basically this is sort of similar to the tilde in per. You still have to wrap this whole thing, but instead of saying function X, you can just do slash and then in parentheses X. So that's a little bit nicer. But that's like sort of the main things you can do. The other thing you can do is use this pipe bind. This is sort of unfortunate though, because you have to set this up as your system environment. So this is not what it is by default, but then you can do something like this, right? And so this symbol here now is just an equal sign and then a greater than symbol. Okay, so there's ways that's nice, but then there's some downsides to it. I personally am probably not. So if you just Google, R native pipe, you'll find. I just clicked on, I think, one of the first ones, but you'll find a whole bunch of different stuff on that. So you can find different blog posts and things. But generally, I am personally probably going to stick with the Magrittr pipe for now, but I'm going to definitely keep monitoring the base R pipe. To me, if I'm doing interactive work, I'm not that concerned about dependencies. I'm really only concerned about dependencies when it comes to creating R packages, which is actually the topic of today. And so if I were to do that, I might use the native pipe, but I might also instead just not use the pipe at all and just write my code slightly differently. Because if you do use the native pipe in an R package, it actually doesn't totally get you out of jail free in terms of dependencies, because it's going to depend on R 4.1, which right now is a super, modern one. I am currently running 4.0.2. Okay, so like if you wrote an R package that depended on the native pipe, it actually wouldn't work on my machine currently. I would have to install the new version of R to get it to actually work. Okay, so again, if we fast forward 5 years from now, all this may be solved and everybody may be using the native pipe, and the native pipe might be nicer than it is currently. But that's kind of just where we're at with that. Okay, any questions on that?
Is there a shortcut for the native pipe?
So there is not currently, but you can set one up in RStudio. You can set up shortcuts for anything in RStudio. So, you know, Command-Shift-M is typically the shortcut for the Magritter pipe, and you could set up something just like that if you wanted to.
Thanks.
Yeah. Okay. So let's go to the topic for today, which is we are at week 10. So this is the final lecture for this class, and it's sort of, I think, kind of a fun topic, which is our package development. And today I will give you a fair amount of background, but then we're actually going to do it. We're going to create a basic little R package. Okay. So maybe what I'll do actually to start is just share this one, and then I will switch to the other one when we're ready. Okay. I was having issues with not being able to see you all again, but I've figured out a pattern that makes no sense, but it works in terms of getting it so I can see you all. Okay, so developing your first R package. So the basics, or the agenda, we're going to talk about the basics of package development. I'm going to walk you through an example with my first package that I ever submitted to CRAN. Okay, it's called SViz, for effect size visualization and estimation. And then we're going to actually create an R package with just one function that's a very simple function. Okay, and we'll do that together. So if you want to follow along, you can do this. Obviously, you should probably already have Tidyverse installed. I modified these slides from like a talk I gave to a more general audience, and so I sort of forgot to modify some of this. But you will definitely need DevTools installed. If you want to do any of the SViz stuff, you could do that too. And then you definitely need RoxyGen2, and you definitely need UseThis. So these 3 packages are for sure required. And you should already have this one, and this one's pretty optional. Okay? So DevTools, RoxyGen2, and UseThis. When you install DevTools, though, I think it installs RoxyGen2, but you can just do that to be sure. Okay, so bundle your functions. We have now talked for quite a few weeks about writing functions, right? When you are writing functions just within one script and you're using it for that script and that's it, then great, just put them in the script, right? If you get to have more of that, more than just those functions, like you're working on a really big project and you have a bunch of functions that you're using maybe across different data sets or something, then you're probably going to want to have some sort of centralized location where you're keeping all of those functions, right? So there's generally 2 ways to do this. You can put all of those functions in a .r script, and then you can just source that script in your analysis script. Or the other alternative is you can write a package, okay? I sort of view these like this, right? This is sourcing. It's easy, it's simple, but it like takes you down this dark path of scariness, right? Whereas writing a package, maybe on the surface, sounds scarier and more intimidating, but if you actually put in that effort, which is not a huge amount more effort, then it'll take you off into this land of sunshine and roses. Okay. All right. So why should you avoid sourcing? Generally, not always, but generally the documentation is going to be much more sparse in a source file, right? So you would go to a .r script and you might have some comments on some functions, but most functions in there are not going to really be documented very well. If you are really using these functions a lot, you also probably want to include things like automated tests to make sure that those functions aren't breaking over time, or when you make modifications to any other function, it doesn't break those other functions. Okay. There's also directory issues, right? You can, which can lead to reproducibility issues. And you can get rid of this a lot by using RStudio projects and using the here package, but there's still some issues, right? So if somebody doesn't have direct access to your source file and it's not in the same sort of directory that they're expecting, then they might not be able to source that file the same way that you do. And so therefore they won't have access to all those functions and they won't be able to solve it, right, to run your script. Whereas if you write an R package, it gets installed on your machine, and then it doesn't matter where you're at. You could be at any directory anywhere because you have the package installed on your machine, and it'll work just like any other R package, right? You would just say library, whatever the name of your package is, and it would come up, okay? Most importantly, bundling functions is not that hard, okay? It sounds intimidating, but as we'll see, a lot of it has been automated. And so if you just run a couple of functions, then you'll have the framework that you need. Okay. So now we're gonna, I'm gonna take a detour for just a little bit, and we're gonna talk about SViz, which was my first package that I submitted to CRAN. Okay. So just quick background, it was on effect sizes, standardized mean differences, but generally, standardized mean differences assume a couple of things. They assume that the distributions for each group are reasonably normally distributed, and that the mean is a good indicator of central tendency for those two distributions. Okay. The difference in the means, however, if that does not hold, may not really reflect the difference at other points in the scale. Okay, so if you just imagine like a test score, and like the lowest score is like 80 and the highest score is like 150, right? Maybe the mean overall is like 120. Well, then you have two groups, maybe it's like a treatment and control group. The treatment group might on average score whatever, 110, and the control group might score 100, right? And if both of those distributions are reasonably normally distributed, then the difference in the mean is going to represent the difference at any point in the scale. But if they're not, then if we look at a specific value, right, like maybe 115, then for one group, it might be like the difference between those groups in terms of the proportion of people who are scoring at that level or below, or at that level or above, might be really different. Okay, so that probably doesn't make a lot of sense, but I'll walk you through an example here in just a second. The other thing is we might not always be interested in the difference of the means. We might be interested in differences at other points in the distribution. So specifically, if you think about statewide testing data, which is a lot of stuff that I do, we have these cut points that basically bin the continuous scale into a categorical scale. So you have very far below, almost proficient, proficient, and advanced, right? And so you have these cut points that are sort of separating this continuous scale into these categorical groups. So you might be interested in the difference between two groups, like treatment control, for like at the cut point that separates the low from proficient or whatever. Okay, so here's a very quick example, and I'm going to do this quick because I want to just move on past this. But basically, I'm creating a tibble here that has common variance. Okay, so 1,000 observations. This one has a mean of 10. This one has a mean of 12. They both have a standard deviation of 1, right? For the different variants, we have the same separation in the means, 10 and 12, but this one has a standard deviation of 1. This one has a standard deviation of 2, okay? If I put those together and then I plot them, they look like this. So when we have common variance, then we're here, right? But when we have different variance, then we're here, okay? And so the point is, this difference that we observe at the mean here, if we have a common variance, is a good indicator of the means for the entire distribution. It's just basically shifting, right? But when they're very different like this, that's not necessarily the case. Here's the mean here, here's the mean here, and we have some difference. But as we move down here, we might see that difference shrink. And as we move up, we might see that difference grow. Okay? So what I ended up doing is implementing this bin defect size thing. So basically we take the x-axis and we cut it up, and then we calculate the mean difference for each sort of section along the x-axis and divide it by an overall pooled standard deviation. And then we can visualize it. Okay, so this is basically what I was trying to get to. Here's bin plot for when we have common variance. So this is the lower, not quartile, but I don't know what it's called, lower third of the distribution, middle third of the distribution, and upper third of the distribution. Okay, and so this point represents the average difference, and you can see it's basically the same at all points. Whereas here, for the group that had different variance, we have a very different difference for this lower third of the distribution than we do for this upper third, right? And so it just kind of goes down like this. So if we're looking at just kids who are in the top third of their respective distributions, there's a big difference between them. If we're just looking at kids in the lower third, then there's not as big of a distribution, okay, or of a difference in the distributions. So that's cool, fine, right? But that's sort of beside the point from what we're talking about today. So the SViz package does this for you, right? Like you can pretty easily take a score on something like a test score or whatever and say, here's the groups I want to see it separated by, and it'll not only calculate those statistics for you, it will create those plots for you. Great. But how did we get from an idea like that to functions to a package, right? These are multiple steps involved here, okay? So taking a step back, this is generally the process, all right? You're going to start by having an idea, okay? That idea does not have to be some brilliant idea that nobody's ever had. In fact, many R packages are internal, right? So they're good for you and the group, maybe the group that you work with. Or maybe they're just good for you, right? That sundry package I've mentioned, I don't know if I've mentioned it in this class. We're actually using it in my other class. It's just a package for me. I use it for teaching sometimes, and I use it for some of my work, and it's not ever going to go on CRAN. It's just for me, right? And that's a really common thing. Tons of people have packages like that. And some people even actually put them on CRAN, but most people don't. Most people just keep them on GitHub or whatever. Okay, so if you have anything that you're just doing a lot repetitively or whatever, then you should consider making an R package out of it, even if you don't think it's going to go to CRAN. Okay, then you're going to write a function after you've got your idea or ideas, or more likely a set of functions. Okay, and this is where I talked about like sort of refactoring. You might have one function that you want it to do a bunch of stuff, but rather than having one function that does all of that, you're probably going to be better off writing 10 functions or 15 functions or 20 functions that all sort of link together to end up with this one thing. Okay, and that one function might be the only one that you export, meaning the only thing that you can actually have access to when you load the package. Okay, even if you have a bunch of other or other functions, those would be called internal functions. Okay, so there's internal functions and external functions, which you export. Okay, then you're going to create a package skeleton, which we'll do today through automated tools using the use this package. Then you're going to document your function. And this is part of why I think writing a package is a nice way to do this, is because documenting your function is not only easy, but then you get help documentation just like you would for any R package. And so it's nice not just for the people who might use your package, but for you too, right? Even my Equasiomatic package, which is probably, well, it has been my most like successful package in terms of other people out there using it. I look at my own help documentation for it all the time, right? There's a way to change the size of the equations, and I can never remember what all the arguments are because I actually didn't set those arguments. They're all linked to LaTeX arguments, and so in the help documentation, I link to a page that has all of those arguments through LaTeX. So I use it all the time, right? And it's my own function. After you document it, then you're going to install, play with it, install some more, okay? And I'll take you through some ways to do this. From there, you could just be done, okay? There's your R package. You could put it on GitHub. People could install it through GitHub just like any other R package, and it's great. Or if you want to be a little bit more careful, you want to have a more robust package, then you would write tests for your functions, okay? And these are basically assertions that say this is the output that I'm expecting from this function when it gets this input. And specifically, you want to do things like, okay, here's a bit of code that should throw a warning when it's run through the function. And here's something that should just output perfectly. And this code should actually throw an error. And this is what the error message should be. Okay, those are tests. Then finally, so this part is very important, but I would argue that it's more important if you're really trying to get serious about writing an R package and it's not just like something you're messing around with. But then finally, you should host your package somewhere. And I would do this regardless. Okay, so even if this is only a package that you'll be using, version control is a good thing, right? It's I hope I've convinced you of that over the 2 terms. There's a lot of reasons to value good version control. And so just for that reason alone, I think it's worth putting on Git and GitHub. But the other thing is, particularly if your package is going to be used by other people, it's a great way to advertise your package, right? You can go to Twitter, you can go to whatever, LinkedIn, if that's what you do, and say, hey, check out my new R package. And people can actually go to your repo. You can have a README that shows what the R package does, etc. The other thing that I think is super nice about this, and I've had happen on numerous occasions, is you will get help from the community for again, this is only depending on if you have a package that actually other people are using, but you'll get help from the community to develop your package. Okay, so when I put out the Equasiomatic package, I put it out there, and like within 24 hours, I had 3 people who had submitted pull requests to help make the code more extensible, right? So make it more, there's more things that you could do with it. With SViz specifically, it later drafts of it, the current draft, uses dplyr and things like that. And so dplyr changed significantly relatively recently, like within the last year. They had a major update, and that was going to break some of my code, and that package is on CRAN. So Hadley actually submitted a pull request to my repo to fix that code so I could resubmit it to CRAN without me having to do the work. And so that's, again, a great way to use the power of open source to make your package better, okay, to work with other people. Final thing, use tools to automate as much as possible, okay? This is another really good point, and this is really good reading. This woman is amazing. If you're not following her on Twitter, you should. But this was her reply to me, or actually Allison Hill, who had tweeted about my talk. But it was actually in response to this slide, come up with an idea, and then she said 1A, check that no one else has had the same idea. And I think that's absolutely true. If you're writing a package that other people are going to use, I think it's less important if it's just a package for you internally, okay? But this is a really good blog post on writing R packages as well. So check that out if you're gonna pursue this. Other resources, again, obviously today is gonna be quick. It's one lecture on R packages. We're not gonna have any like assignments on writing R packages or anything. This is all just kind of fun extensions. But these are going to be your primary resources, right? Advanced R is a great book. We used parts of that throughout this term. And then this book is actually currently, I believe, being revised for a new edition with Jenny Bryan coming in as well. So that's a good package, or a good book as well. Okay, so our package that we're going to do today, we're going to write a very simple package that's going to have one function, okay? The idea, which we've actually used before, is we're going to feed it a vector, and it's going to return some descriptive statistics for us. Okay, so the vector is just going to be some generic vector x, and then we're going to have n, the number of observations, n valid, the number of non-missing observations, n missing, obviously the number of missing observations, and then the mean and the standard deviation for the non-missing data. Okay, that's what it's going to report. So we can do this a bunch of different ways, right? I would say we should probably have it so it returns a data frame. Okay, so just looking at this, thinking about this, there's a couple of different ways that we could do this, right? But so just think about it for a second. What will the formal arguments be if we're going to do that? Okay, and then thinking about that more, once you know what the formal arguments are going to be, how do you think the body would look? Okay, and I've asked if you want to give it a go, but I think I'm going to give you just a second to think through this still, but I think it's probably going to be better for us to just move on so we can get to the actual package development stuff. Sound good? Okay. All right, so still think through this for just a second. What do you think the formal arguments would be, and what do you think the body of the function would look like? And there are multiple ways to do this. Like always, this is the way that I would do it. Okay. I tend to like to have functions that start with data as the first argument. Okay. You could also just have x. So it's just going to have a vector that you're feeding it. But I tend to like to have the data as the first argument. So data is going to be the first argument, and then column name is going to be the second argument. Okay. We could use dplyr and non-standard evaluation for the body. In this case, I am not doing that. All I'm doing is saying data, double bracket, column name. So that means column name is going to be a string. Okay, we're assuming that's going to be a string. All right. So this part's going to extract just the vector to summarize. Then we're going to actually compute those things. So first we're counting the non-missing, the length of na.omit. Okay. Then we're going to count the missing, sum is .na, x. Then we're computing the mean, removing missing data, computing the standard deviation, removing missing data, and then we're going to just output the whole thing in a data frame. Okay, so we have n, invalid, n missing, mean, standard deviation, and it's just going to be those things. Okay, so the n is, I have as nval plus nmiss. You could also just say the length of x. That would be fine too. Okay, and then out at the very end is what we're going to return, right? So we can return it like that. We also could just omit this altogether and just have tibble, and that would be the exact same thing. Okay. Questions on that? Okay. Now we're going to do some informal testing with this. So I'm going to set a seed, create a tibble where x is equal to 100 random normal observations. And then df2, same thing, but now I'm going to have 1,000 observations, mean of 10, standard deviation of 4, and then I'm just going to add 27 missing observations to it. Okay, so when I say describe df1 x, I get 100, 100, 0 missing, mean of 0.05, I was expecting 0, standard deviation of 0.93, I was expecting 1, so those are close, so we're good, right? Describe df2 var miss, 1,027 total observations, 1,000 valid, 27 missing, mean of 9.88, I was expecting 10, standard deviation of 4.09, I was expecting 4, and obviously those are not going to be exactly the same because we are randomly sampling from those distributions. They're not exact. Okay, so this is informal testing. We're just sort of playing around with our function to make sure it's working as we would expect it to work, and it is, so we're good. Right? Okay, now we're going to actually move on to the demo part, and I would like you to follow along. Okay, so this is where we're going to create a package skeleton. First, we're going to say use this create package, and I'll show you this in just a second. But what that's going to actually do is it's going to close your current R session, and it's going to open a new project that has the same name that you have, and it's going to have all the infrastructure for a package. Okay, then I'll say use this, use R. What that's going to do is create a new R script for me to put my function in. Okay, then within that function, we're going to use RoxyGen2 special comments for documentation to add the documentation for like a help documentation. Then we're going to run DevTools document. That's going to actually create the help documentation. And then we will install, restart, and play around. Okay, so you'll probably want to come back here and get this code copied. And then the rest, oops, we can do together. Okay, so let me switch my share. Actually, I'll just share both like I was going to originally. Okay, so now we're first going to say, I'll do it down here. Use this, create package. Okay, and then the path, I'm going to say, I'm just going to put mine on the desktop, which is going to be here. And actually, I need to go to the help documentation for a second because I'm not sure I remember. Path, fields, or studio name. Okay, so I think the path is going to include the name. If it does not exist, okay, let's just try this. I think I'm going to say desktop. You could use here or whatever. Well, actually, here wouldn't really work. My package. Okay, so on the desktop, I'm going to create a new package called my package. Okay, at least I think. We'll see if this works. Okay, so it's saying it's doing all this stuff, and then it did it. So I need to close this, and then you will see, once I get my Windows set up here, hang on just a second. I'm just switching my share now to the other RStudio that it opened for me, and this is what it looks like. Okay, so this is my package. Okay, so that's the thing that I'm calling my package, and it's got a get ignore for me. It's got a R build ignore. It's got a description, and it's got an R proj that is whatever I called it, right? My package. It's got a namespace, which we're not ever really going to worry about, and then it has this R folder. Okay, that R folder has nothing in it yet because we haven't made anything. Okay, so go ahead and give that a try. Give me a thumbs up once you have that and you're ready to move on.
Daniel, I think you just said this, but I'm getting an error about the path being missing for create package. Can I just use here, and just it will automatically just put it right where I am? That's fine.
I don't think you can, because that would probably be creating an R project inside an R project. So
oh, gotcha. Okay.
Yeah, so you probably want to set your path to somewhere else on your computer. And so just as a very quick FYI, one thing you can do is if you open up like terminal or something. So let me just go to this real quick. So here I have terminal, right? If I just grab something, so like let's say I go somewhere where I want this thing to be, and I'm just like going to some random place, right? You can just grab that folder and drag it into terminal, and oops, like that, and it will just paste the path for you. So that's one way you can do this, and then you can just copy that path. And I don't know if you can do that. Let me switch my share. I don't know if you can do that through this terminal. Let's see if we can try. And so like I would probably go, let's say here. No, that doesn't work. Okay, so you have to do it through your other terminal, or you just have to know paths. Okay. Other questions?
All right, I lied and it's not working. It's telling me that the path doesn't exist, and I specified it correctly as far as I can tell. But I'm in a project. Should I not be in a different project? Will it not work then?
It shouldn't matter because it's going to create a new project for you. When you do your path, though, you also need to make sure that, like, so, you know, your path could be like users, Daniel, desktop, but then I would need to put the name of my package as the last part on that path.
Gotcha, that might be it.
Package. And then, yeah, that should work. Okay, let's go ahead and move on. Let me get my share back so we can see both of these things. Okay, so now that we have this, right, this is our R package, and we can see that because we have this description, and we have the namespace, and we have an R, it says the name of our package up here and here. So we're in our R package. So that's cool. We actually already have an R package right now. It just doesn't have anything in it. It doesn't have any functions. So we're going to create our first function, right? We're going to write the first function for our package. So now we say use this, use R. Okay? And then you can just hit enter. Oh, no, you can't. Let me look at this. Name. Okay. Either a name without extension or null to create the paired file. Yeah. It should just work like that. How come that didn't work? Argument is not a character vector. Okay, well, fine then. I will say describe. There we go. Okay, so use this, use R, and then for me, I had to put the name. I don't remember always doing that, but that's fine. Okay, so now if I look in R, I have this describe.r file, okay, and that's here. And generally, this isn't this isn't really any different in this small case than just creating a new R script and putting it in that folder, all right? Where this will become different is if you write tests, because when you say use this, use R, if you have testing infrastructure set up, then it will also create a file for you to write your tests. So it'll create both at the same time, which is nice. Okay, now within here, we're going to actually write our function. Okay, so I'm going to come back here. I'm going to copy the code from my function, and I'm going to put it here. I added a couple of lines here because I wanted to. You'll see why here in just a little bit. We're going to actually, this is where we're going to write our documentation. Okay, but for now, I'm just going to save that. And now what I can do is over here in this panel, you see this build tab. You can click on that, and then you can say install and restart. Okay, now at this point, you have a package that is called my package. For me, yours could be called whatever you called it, right? That is on your computer. So I could literally quit this, open it again, and I would have my package. Unfortunately, at this point, we also have not exported any functions. So this function exists, but it's only internal to the R package currently. Okay, it doesn't exist outside of the R package. So this actually isn't very helpful yet. So what we need to do instead is write these Roxygen2 special comments. Okay, so let's talk about that for a second. When we're doing this, they're always going to have this hashtag and then a single quote. Okay, that's how we start. And so we can do this just right up here. Okay, and the first thing I tend to do, and that I would encourage you to do as well, is to write like the name of the function, right? Like a textual description. So describe a vector descriptively. Okay, describe it descriptively. Right? Okay, so that's cool. And then what we're going to do is we're going to add in arguments to that function. Okay, so I have two formal arguments, data and column name. All right, so what I'm going to do is use the @ symbol. And notice I have all of these that just pop up for me. These are all Roxy Gen 2 things. Okay, and I'm going to say param. Okay, so param means parameters to the function. All right, and so I have data. That's my first formal argument. Now I'm going to put the description of that. So I'll say the data frame that includes the column to summarize. Okay. And I'm going to actually say summarize a vector descriptively for my title. Okay. And then, let me pull this over a little bit. I go down again. I'm going to add another param flag and say column name. Okay. Then I will say a string. So notice I'm telling the user, who's probably going to just be me, what that is expecting in the argument, right? A string stating the name of the column in the, and then you can do things like this, although you don't have to, code data to summarize. Okay, and I tend to not like to go beyond 80 characters, so I have this vertical ruler set up, and then I just return from there. Okay, then there are other things I might want to do, like, for example, I might want to say return, and then I would tell you what this function is going to return. And so I would say, in this case, a data frame including the number of observations, code n, number of valid, non-missing observations, code n valid, and then I'll just go like that, etc. Right? I would describe the output. Okay. I could also include examples of what this code is going to look like when I run it. Okay. I'm not going to. Well, sure, I'll do that too. Why not? Okay. So I'll say examples, and then examples is going to be a little bit different. I think we're going to do curly braces like that. All right. And then I would just say, like, describe empty cars and then MPG, right? And then it should output that. All right. Now, the last one that we're going to include here that is very important is this export. And it actually can go up here. And I actually always have my examples as the last thing, so I would put it here. So I would say export here. Okay. And what that's going to do is that's going to actually export the function. So therefore, when you load the package, it's there for you. Okay. If you don't have that export tag, it's going to be an internal function that your users, which is you probably, can't actually access easily. You can. You just have to use 3 colons instead of 2. But it's not like it's not attached. So it's not there when you load the library. Okay, so that's cool. Now we're going to save this. I'm going to install and restart. And now, notice it says library in my package. Let's try. So let's try exactly what we just did. Empty cars, MPG. Could not find describe. Okay, why is that? Well, the issue is we actually haven't run any of this part. We've done it, but we haven't actually run it. Okay, so to run it, we need to run this other part back here, DevTools document. Okay, and so if we come back here, you will see this namespace. I can open this up. It says generated by Roxy Gen 2. Do not edit by hand. That's good advice. Don't edit it by hand. If you want to, you can actually trash that thing altogether if you start to run into problems, and it'll automatically regenerate it. Okay, it's generated when you run devtools document. Okay, so now it says writing namespace, writing describe.rd. Okay, so now I have this man folder. I have describe.rd there. If I look at the namespace here, now it says export describe. Okay, so that's cool. Now I need to install and restart again. Okay, now I have library my package. All right, now let's try this. Describe mtcars mpg. And there it is. Beautiful, right? What's even cooler is we can now do question mark describe. And there's 2 of them. So this is from my package, right? So I can click here, and here's the help documentation. So this is what we wrote, right? And here's how it comes up. My example didn't work, though. Let me try this way. DevTools document, install, restart, and then describe here. Yeah, it still doesn't work. Whatever. I don't remember why. You could just actually paste in this there too. So I could do something like this. And then I would just go. Okay. And that would work. So I'll try that one more time. DevTool, let me save this. DevTools document. And then install and restart. And then question mark describe. And there we go. So that looks pretty good, right? So that's probably what I would do. Okay, so that's all good, all right? And now the thing that is cool about this is I can literally start, like, here, I'll do this. We can create like a new, like I can quit out of this entirely, create a new RStudio, like go to a new project entirely. So I'll go to, I know you can't see this, but just 1 second. Okay, so now notice I'm in C3 FP 2021. So this is the R proj for the course, right? But I can still do library describe, or not describe, my package, right? And it works. So now I can do describe. Let's do something different. Let's see. Well, whatever. I'll just do empty cars and then do sil instead. Okay. So that works too. Okay. So this is now an R package, just like any other R package. It's installed on my machine, so I can use it in any R session. I don't have to source the thing. I just have to say library my package. Okay, so let me close this, and then I will open back up the R project for this package. All right, questions on any of that? That is really the basics of writing a package, okay? That you have a function or a set of functions, and then you say create R package, and then you say use R, and you write your thing, and then you add some special comments to it, and then you have some documentation. That's basically it, okay? If I were to, at this point, push this whole thing to GitHub, then I could install it, or anybody could install it on their machine just using the install_GitHub, like remotes install GitHub, just like any other GitHub package. Okay, so that's pretty neat, I think, in terms of being a pretty powerful and easy way to share all of your functions. Okay, So that's the basics of it. Let's talk just a little bit more about some of the more just more information about packages. Okay. So hang on, I'm just getting my screen set up. So the namespace, as I mentioned, is created by Roxygen. Okay. And this is going to manage everything that you have. So you're going to probably import some functions or some functions from some other packages, and you're definitely going to be exporting some functions. Okay. You also may have other functions that are in your R package that are not exported. Okay. So they're not like user facing. The description is another one. So again, you'll never modify the namespace by hand. You'll let Roxygen do that. The description is another one, and this one you will modify. Okay. So the package is by default already what you put your package name to be. And then here you would write whatever the title of your package is. Okay. And then your version number, this is what it starts out as. You can read in the book about versioning R packages, but the most important thing is this 0.9 at the end means it's the development version. Okay. So what you typically tend to do is you would create 0.1, and then that's like a major version. That would be the first one that you'd push to CRAN, 0.1.000. You push that to CRAN, then you would switch it pretty much immediately to 0.1.0.9. That indicates it's the development version. You're making changes, then maybe you just have some bug fixes that would turn to 0.1.1, then maybe 0.1.2. And then you have some new features and new developments that you're bringing out. That would be 0.2, okay, instead of 0.1.2. And then maybe much later you say, okay, this is the stable version. This is it. It's built. It's complete. That would be 1.0, okay? Then from there, it's like a book, right? So your book is published. Here's version 1. And then from there, you might say, okay, well, I'm going to update some of these chapters. So that's 1.1, version 1.1, or maybe 1.0.1, whatever, if it's bug fixes. That's sort of how it works briefly, okay? Then you would add your authors. So generally, it's going to start out, depending on how you have your R profile set up, this already might be filled out, but you would be the author and creator, okay? You can put your email and then your ORCID ID as a comment if you want, and that'll add a little symbol with it. Description of the package, and then license. We'll talk about license more here in just a second, and then just a few other things, okay? So this is all by default, so you will want to modify this. This is one of the first things that you'd want to do, okay? One other thing is you are the author and creator. If there's somebody else who is contributing to your R package as well, and they're going to be heavily contributing, then you would probably want to add them in as an author. Okay, so the way that you would do that is you would just do C, like a vector, right? And then you do comma, and then you would just add another person like this. Okay, so this is going back here. And this is just like generally. So that person might be an author, okay? Not a creator. You're the author and creator, but that person might be an author, okay? The other one that is very common is CTB, okay? That stands for contributor. So most people, myself included, are contributors on far more packages than they are authors, okay? So a contributor is anybody who contributes to a package. So maybe you supply a bug fix for a package. That would make you a contributor. Maybe you extend the functionality of one of the functions a little bit. That would make you a contributor. So contributor is different than an author because your contributions are sort of come and go, right? You sort of swoop in, solve a little problem, and then you swoop out, and that's it. You're not an author of the package, but you did contribute to the package, okay? So if you are a package developer yourself and you have it on GitHub and people submit pull requests and they are helping you in any way, like you merge their pull request in, then you should also add them as a contributor, right? It's just a sort of courtesy thing to do. And the easiest way to do that is just to say, hey, thanks, this looks great. Can you modify your pull request so that you're editing the description to add yourself as a contributor, okay? And because that way they can add their email if they want, or maybe they don't want it, so they won't, and they can do their ORCID if they want, right? They are in charge of doing all of that stuff, not you, okay? All right. The man part stands for, I can't remember what it stands for. But it's all the documentation. So this looks like this. This is again created by Roxygen, so we don't want to modify it. But this is like basically the same stuff that we had before in Roxygen 2 comments, but this is like the actual code that it needs to create the documentation. Okay. So again, that's not anything that you're going to do on your own. So real quick, this also, the description is where the citation is going to come from. So like right now, if I said citation, and then the package would be my package, it would say no date field. So I should add a date field in here, and could not determine the year because there's no date field. Okay. But this is what it's going to do by default. It's going to say, okay, to cite package, my package in publications, use first, last, NA, because that's what I have here, no date. And then my package, what the package does, right? So this is all just like taking this stuff from here. And then our package version, blah. It'll also create a BibTeX entry for people as well. Okay. One other piece of advice for this. So this description is basically just a text file, but you should not edit this in something like TextEdit or Word for sure. Okay. You should edit it either directly in RStudio, like I'm showing here, or in a good text editor like Sublime Text or VS Code. Okay, the reason is because you can get those like curled quotes and things like that that'll just screw up, and your R package won't build, and it'll be frustrating, and you won't understand what's going on. So just avoid that. Okay. You can also add additional fields to this. So some fairly common ones are like URL and bug reports and a license. We have license in here, but it's not actually set really. And then lazy data. So these are all things, additional things that you can include in here. So like specifically the URL and bug reports, those are good. URL is just going to be a link to your GitHub repo. And then bug reports is going to be a link to the issues part of your GitHub repo. So you can do that. This is like an actual description from SViz. So it's just me on this one, but here's the description. You can see it's relatively long. And then it has these depends, which ours does not have that by default. And then it has all of these different imports. Part of the reason I'm showing this is because this one has more imports than most of my packages. Here's the URL, like I mentioned, and here's the bug reports. Here's the license. We'll do the license here in just a second. All right, so you can change the name and everything if you want, but for now, let's actually add a license, okay? So what I'm going to do is just down here, I'm going to say use this, use, I actually like the CC BY license. That's probably my favorite. It's a very permissive license, so it allows people to copy and edit and modify your code, but so they can do whatever they want with it, basically, but they have to supply attribution. Okay, so they have to say this code was modified from Daniel Anderson. Here's the GitHub repo, etc. Okay, so that's actually my favorite. So let's use that one, but you can use whatever one you want. If you want to use the MIT one, that's fine too. So I just say use this, use CC BY, or use MIT license, or whatever, and then it notice it modifies that. Okay. So the license now says CC BY 4.0, okay? And if I come back here to my root directory, you can see I now have this license.md, okay? I can open that up and you can see it's this big long thing. This is the full license. You can read that if you want. But. All right. It also does some other things, like it adds the license to your R build ignore, which is here. So it's going to not include our project. It's not going to include that license, when it's actually building the package, because those are illegal things for R. Okay, so then again, we would install and restart. Okay, and then we're going to declare dependencies. Before we actually do this, though, what I would like to do is actually skip ahead to this part. I don't want to talk about tests yet. All right, checking your R package. Okay, so there's a bunch of different ways to do this, but DevTools check is the main way. Okay, what it's going to do is, like, if you were to submit your package to CRAN, right, it would run through a whole bunch of automated tests. If any of those tests have a warning, or is for sure an error, or even a note, so those are the three things you can have: error, warning, or note. Unless it's your first submission, in which case you will have a note, then CRAN's not going to accept it. Okay, it has to pass all of those automated tests free and clear without any problems. Okay, so you can run DevTools check to do that on your R package, or you can actually just click this button right here that says check. Okay, so I'm going to do that right now. So I click check, and notice it's doing a whole bunch of stuff now, right? So checking package dependencies, etc. This is the full check that CRAN would do. And we got one error, 2 warnings, and 1 note. Okay, so that's less than ideal. So what do we have going on here? So it says checking R code for possible problems. Note, describe no visible global function definition for na.omit. Okay, that probably doesn't make a lot of sense, but if you come down here, it says consider adding import from stats na.omit sd. Okay, because it also has that same warning for sd. What this is saying is that we are relying on the na.omit function and the sd function, which both come from the stats package. Okay, but we actually haven't declared those as imports, as dependencies. Okay, we also have other dependencies, but let's add those first. Okay, so when we do that, my preferred approach is like this. Okay, first we say use package, and then we say the name of the package that we're going to use. So I would say use package, and then I would say stats. Okay, and then what that's going to do is, if I look at my description here now, you can see it says imports stats. Okay, then there's many different ways to do this. But my preferred approach is to also create package level documentation. Okay, so the way I'm going to do that is I would say use package doc. Okay, and now when I go into my R folder here, I have my package-package. So it's the name of your package, whatever it is here, .package. Okay, and this allows you to now do question mark on the name of your package, and it will bring up documentation also. From here, I am going to actually declare my dependencies. So I would say now, so let's see, what's it? I would go like this, and then I would say import from stats, and then I'm going to say the functions that I want to import. So na.omit and sd. Okay, and what's important here is you can say import stats. That'll import the entire stats library into your package, but you don't want to do that. That's really poor form, because then when somebody loads that, it'll load all of the stats functions, and that's very likely to end up with conflicts with things that they're working with. Okay, in addition, it will make things on your end more difficult, because you might run into internal conflicts within your package. So I don't see that with things like stats all that often, but I do see really, really regularly people who are importing all of ggplot into their packages, right? So you don't want to do that. You want to only import the functions that you're using. Okay, so I'll do that. Now I'm going to say DevTools document. All right, and now let's look at the description. That's all good. That's still the same. We'll say install and restart. And now I'm going to run check. I'm still going to have problems, okay? But I just want to see if I've now taken care of that problem specifically with na.omit and sd. Okay, and I did not fix those, and I was worried about that. I think I put these in the wrong spot. I think this needs to go up here. All right, DevTools document. All right, now install and restart. Check. The other thing that is nice about this sort of an approach is that it will make it so that you do not have to. I still ended up with that. What am I doing wrong here? Hang on just a second. Let me look at some other code. I'm sorry. Oh, right. That's why. I forgot the @ symbol, import from. That's why. Okay, so get rid of this now. Try this one more time. DevTools document, install and restart, and then check. Okay, so we still have problems, but that specific one is no longer there. Okay, and so one of the ones we're having problems with is that this example. So I always get messed up on how to write examples also. So I have to look back at, let's see, maybe extracting. Look here, this is for an actual R package I have examples. Okay, so it's just like that. All right, so I just need to say, I just need to get rid of this part. Or I think actually, rather than doing that, I think what I can do is just include all of this commented out. I think that should work. Let's try that. And then if that doesn't work, I'll just give up because who cares? All right, install and restart and check. So a couple other things while this is running. This part, doing this import from stats na.omit and sd, makes it so that when I'm actually writing my function here, I do not have to do something like stats sd. Okay, I do have this with Tibble, and I'm getting 0 errors, but I'm still getting 1 warning now. So I got rid of that one, but it says import not declared from Tibble. Okay, so this is another thing I have going on. So I have to do this now again, where I'll say use this, why isn't this working? Hello, there we go. Use this, use package, Tibble, right? So now when I go to my description, you'll see stats and Tibble are both there. Okay, and then I can come back to here, and then I can say, all right, and now also import from Tibble, import Tibble. Okay, and then over here on my describe, because I've done that import Tibble, I can actually get rid of that part. Okay, so I'm going to just go. Okay, and now I'll go DevTools document, install and restart, and check. And I think we should be good at this point. It should be passing everything. All right. Yay, everything's passing. Okay, so we now have a functioning R package. It has documentation. We can do things like this. So I can say $my package, and it will come up here like this, right? And it tells me who the maintainer is. That pulls from the description. I can also click on the index here, and I can see I've got one function called described. Here it is, and there's an example output. Okay. So the other thing we might want to do is write tests. We only have 5 minutes left, so I'll set up the testing structure, but then I'm just going to move on. All right. So what we do is say use this, use test that. Okay. And then I just run that. It's going to do a bunch of stuff. If I look at files now, back here, notice I have this tests thing. Okay. I have test that here, and then when I do test that, I would need to create a test.r here for describe. Okay, and then I would write some tests. I'm not going to do that right now, but basically you would do things like this: expect equal, expect warning, expect error, and then you would feed your function different things, and it would expect that kind of output. Okay, if you're interested in this, here's some resources for it. This is, if you're writing a bigger R package or one that is used out there a lot, this is super important. All right, let me just real quick show you, like with Equationmatic, what the testing infrastructure looks like. With Equationmatic, we also use sort of a slightly different testing framework, but so here I go down to tests, test that, and here's all the different ones, right? And so like if I look at the Elmer mods, there's all of these different tests, right? And the thing is, the way that you typically do this is you will write a function, it'll be working out there, and then somebody will file an issue and be like, this doesn't work. And then you're like, oh, okay. You fix the bug, and then you write a test for that bug. The nice part about all of this is that then when you're doing new things, so when you're writing new tests, or not writing new tests, when you're trying to fix bugs or you're trying to extend the capabilities of your package or whatever, you can work on it all knowing that everything is, that you're not breaking anything else, because those tests are checking everything and making sure you're not breaking anything. When you run DevTools check, like we just did a bunch of times, it'll run through all those tests also. Okay, so if you do something that breaks something else, you'll find out because it'll break a test. Okay, so it's super nice. Really, really recommend doing that if you're going to be doing this more for real. A couple of other things. There's this DevTools check RHub. So there's this builder RHub thing. You can basically package up your package to like a tar file, and it'll ship it out to here. It'll then run it on a bunch of different operating systems and a bunch of different versions of R, and it'll send you a report on if it's breaking on any of those. Okay. You can also use build when, which runs the checks actually on CRAN's computers. Okay, that's a system that CRAN built, and DevTools will automate all that for you too. All you have to do is run these functions. It'll take you through some questions to have you check some things, and then it'll do that. When you get ready to submit to CRAN, you just use DevTools submit. I think it is DevTools submit CRAN. Yeah. And then you can do that, and it's like, is your email first dot last? And I'd say no. And it's like, okay, well then I'm not going to submit. but it'll take you through a bunch of things like that. It'll say, did you do this? Did you do this? Did you do this? To make sure that you do as many checks as possible before you actually submit to CRAN, but then it'll do all of it for you, okay? So the other thing is be patient with this, right? It's going to be frustrating, especially running those checks. But ultimately, I do think it's worth the effort. We've done that. Okay, so you have an R package. Hooray! And a few other things. So like by default, you have a, you do not have a README at all, I guess. So you can do use this, use README RMD. No, not MD, RMD. And the thing that is nice about this now is this part you just don't even include. And then it says my package starts it. And then it gives you a little bit of a sort of the goal of my package is to blah, blah, blah. You can install it like this. And then you provide some examples, right? And then when you upload this, so then you would knit this thing, right? And then it when you upload this to GitHub, it will actually upload the readme.md, which is generated from the readme.rmd. And so then it will be like a nice, you know, so for example, if I go to Equasiomatic, right, this is all generated from a readme.rmd. And then you can see it's like a very quick, this is what the package is about, this is what it does sort of thing. Okay. All right. That's about it. There's also this good practice package. It's pretty nice. And GitHub Actions is super cool. You can run all of your tests automatically on GitHub every time you push, which is really cool. But it takes a bit of extra time setting up. Okay, so that's all. So that is the course. And this was obviously a very quick introduction to package development. But if you are interested in it, hopefully this will get you started. And then if you run into issues, even if it's, you know, a year and a half from now, please do feel free to email me. I love this kind of stuff, so I think it's super fun, and I'm always more than happy to help people write their own R packages. Okay, and if you continue on with the specialization, you want to do the Capstone. We had quite a few people that did R packages for their Capstone as well. Okay. Okay, so that's the course. Your final project for your groups are due next week from today. Otherwise, get in touch with me if you need help, and see you when I see you, I guess. Maybe in real life at one point.